Welcome to Joey's Tech, my friends. In this video of Joey's Tech, you are going to learn to solve a coin change to problem from Leetcode. We are going to solve this problem using the dynamic programming technique. So why not go directly to the problem statement? You are given an array of coins. Basically, these integers represent coin denominations. In our example, 3 coins of denominations 1, 2 and 5 are given. Note that these coins are in infinite supply. Now you are also given an amount. Let's say in our example it is 5. So you need to find out the number of combinations of these coins of denominations 1, 2 and 5 that make up this amount 5. So if the amount is 5, then there are 4 combinations using the coins given which are possible. In the first combination, 5 is being formed by 5 coins of denomination 1. In the second combination, 5 is being formed by 3 coins of denomination 1 and 1 coin of denomination 2. In the third combination, 5 is being formed by 2 coins of denomination 2 and 1 coin of denomination 1, and in the final and the fourth combination, 5 is being formed by using a single coin of denomination 5. Thus there are 4 combinations possible. So this number 4 is what our dynamic programming algorithm must find out. So let's now move to discuss the dynamic programming approach using which this problem can be solved. But before that, I humbly request to you to subscribe to my channel and hit the bell icon if you haven't done it already, as that way you won't miss out on these dynamic programming videos I create for you. There is a video I made on the problem of minimum coins change. In that video, I showed how to solve this problem of minimum coins change using dynamic programming using a single array approach. I suggest you watch it first and then resume this video. You can find that video in the I button. So I used the same single array approach to solve this problem, but it didn't work out for me. Thus, I took the liberty of coming up with the tabular approach. There are 2 pillars already available. Number 1 is the amount, which when counted from 1 to the value forms the columns, and number 2 are the coins that are forming the rows. Okay, there is a 0th row and a 0th column that we are also going to put in this table to facilitate the algorithm. You'll understand why we did that in a while. There is one more prerequisite that we need to take care of, which is filling the 0th column with 1 and the 0th row with zeros. Alright, again I must say that you are going to understand why we did that in a while. Now we start from this cell. So in how many ways can we form the amount 1 using the coin of denomination 1? It's simple, only 1. So we put 1 over here in this cell. Currently, we are using common sense to understand the approach. From the next row onwards, I'll tell you how the algorithm is going to make the calculation. Moving to this cell, in how many ways can 2 be formed using coins of denomination 1, given that the coins are in infinite supply, obviously. So again, the number of ways will be 1. Okay. Similarly, all the subsequent amounts can be formed in one way using coins of denomination 1. Now let's move to the second row. We now have 2 coins in consideration, the coin of denomination 1 and the coin of denomination 2. The key to this problem lies in understanding that there are 2 scenarios pertaining to any amount. For example, if the amount is 5, then the number of ways in which this amount can be formed only using this coin of denomination 1, and number 2, the number of ways in which this amount can be formed using the coins of denomination 1 and 2. Okay, so in scenario 1, 5 can be formed only using coins of denomination 1, And in scenario 2, 5 can be formed using coins of denominations 1 and 2. This is the key. Actually, this is the key to many dynamic programming problems. Now, when the amount is 1, then in how many ways can we form 1 using the coins of denominations 1 and 2? Common sense says only one way. How the algorithm is going to derive that but? It's going to look at this cell, which contains the number of ways to form the amount 1 using only the coin of denomination 1. It's going to take this value and first populate in this cell. Okay, and then it will check if 2 is less than or equal to the amount 1. Since here 2 is greater than 1, hence it cannot form the amount 1 in this universe. So the algorithm is not going to do much in this case, especially. It's going to simply populate this cell with the value of this cell, and that's it. It will move ahead. So the algo moves ahead now. The amount is 2 now. So the algo is first going to take a look at this cell, which gives it the number of ways to form 2 using only the coin of denomination 1. Okay, so it's going to populate 1 into this cell. Now the algo will check if 2 is less than or equal to the amount 2 over here. Yes, it is in this case. So what it is going to do next? It is going to subtract this 2 from this 2, which is going to give it 0. Okay, so the algo is going to go to this cell at column 0. And what's the value over here? It is 1. So it is going to add this one to this one. All right, which will make this cell's value as 2. Hence, there are 2 ways to form 2 using the coins of denominations 1 and 2. Now, what's the logic behind it? Subtracting 2 from this amount 2 takes us to the amount, adding 2 to which gives us this amount 2 only. So hypothetically, if 0 could be formed in one way using the coins of denominations 1 and 2, then there is also one way in which 2 can be formed using the coins of denominations 1 and 2. When we add 2 to this 0, we get 2. That's the logic. And now you understand why, to facilitate the algorithm, we kept this 0th column as 1 only. Don't worry if it sounds complex at this point in time, because this will be very clear to you in further cases. Okay, so the algorithm is going to move to the amount 3. Now the algo is first going to populate this cell with 1, because there is one way in which 3 can be formed using only the coin of denomination 1. So let's populate this cell with 1. All right, now in the second scenario, when the amount is 3, let's see it from a different perspective. Let's say if the amount is 1, and if we add a coin of denomination 2 to it, we get the amount as 3. Now the number of ways in which 1 can be formed using coins of denominations 1 and 2 will be the same in which 3 can be formed using the coins of denominations 1 and 2. So the number of ways is 1 in which the amount 1 can be formed using coins of denominations 1 and 2. So there will be only one way in which 3 can also be formed using coins of denominations 1 and 2. And how we reached this column? By subtracting 2 from 3. Okay, the value over here is 1. This one, when added to this one, is going to give us 2. Hence, there are 2 ways in which 3 can be formed using coins of denominations 1 and 2. Now the algo moves to this amount 4. So it's going to first populate this one over here. This one indicates the number of ways in which 4 can be formed using the coin of denomination 1. 2 will be subtracted from this 4, which is going to take us to this cell of this row only. Here the value is 2. What does this mean? That 2 can be formed in 2 ways using coins of denominations 1 and 2. 1 and 2 both included. Alright. So this 2 when added to this one is going to give us 3. Hence there are 3 ways in which 4 can be formed using coins of denominations 1 and 2. Okay. Note that this value over here includes the number of ways using the coins of denominations 1 and 2, and this cell gives you the number of ways in which this amount can be formed only using the coin of denomination 1, and this cell's value is the result of the addition of these 2 values. Alright, now the algorithm moves here. The amount is 5, so it will be 1 first, which will be populated, and then 2 subtracted from 5 is going to take us to this cell only. That means there are 2 ways in which 3 can be formed using coins of denominations 1 and 2. 2 when added to this one is going to give us 3 only. I hope now you understand why we kept the values of this 0th row as zeros, because even though we calculated these values using common sense, but the algorithm is going to derive the first value from here only. Okay, now we move to the 3rd row. Now the coins are 1, 2 and 5. Alright, the amount is 1. Now the algo is going to come over here in this final row. Here in the second scenario, 5 is the denomination that will be considered along with 1 and 2. Alright, and you can see that all these amounts from 1 to 4 cannot be formed using the coin of denomination 5 because they are less than 5. Okay, so in all these cases, these cells will be populated with the values of the cells above them. So let me straight away populate these cells with the values of the cells above them in the interest of time. So this cell will be populated with 1, this cell with 2, 2, 3, and we now come here to the final cell. In this cell, first the algo is going to populate the value from this cell. So 3 will be populated over here. Okay, that means the number of ways in which 5 can be formed using only the coins of denominations 1 and 2 has already been considered. Now since 5 is less than or equal to the amount 5, so 5 will be subtracted from 5, which is going to take the algo over here. The value over here is 1. This one will be added to this 3, which is going to make this cell's value as 4. Okay, and this cell gives us the number of ways in which we can form this amount 5 using the coins of denominations 1, 2 and 5, which are in infinite supply. Problem has been solved using the dynamic programming technique. You will find the working code to solve this problem on my GitHub link, which you can find in the description box of this video. And with this, we have come to the end of this video. I hope you enjoyed learning this dynamic programming problem from Joey's Tech. Let me know in the comment section if you have any doubts related to this problem. I'll see you in the next video of Joey's Tech. Goodbye and take very good care of yourself.